Welcome to Cut the Crop, keeping you in the know about everything you grow. Researchers, growers and other interesting folk delivering insights and information on topics ranging from agronomy to profitability. Brought to you by the Foundation for Arable Research.
Hello and welcome. I'm Alison Stewart and I'm your host of Cut the Crop. And today we're going to be talking to Carolyn Hedley from Manaaki Whenua Landcare. And Carolyn's been the programme leader of a large government-funded 6-year programme of work called Maximising the Value of Irrigation. And Carolyn's here today to just tell us about, what the programme is about and what are the key outcomes from the programme. Welcome, Carolyn.
Thank you, Alison. Well, thank you for inviting me to talk to you today. Yes, I'm a soil scientist with Manaaki Whenua Landcare Research, and I've spent the last few years looking at ways to improve management of our irrigated land. And so we had this big 6-year MB program, Maximising the Value of Irrigation. And really a focus of that was to develop new sensor technologies that could map and monitor the soil and the crop at high precision so that we could fine-tune irrigation to the variable needs of the crop across one field. So in the past, farmers have known that this variability exists, but we haven't always had the tools to manage that variability. But now with some of our precision mapping and monitoring methods, we're better placed to manage that variability that exists in the field. So the results of our trials, we ran trials in a number of regions, and we showed that we could save water between 5 and 34% by this precision irrigation scheduling. Now, saving water is good because that saves money and energy from less pumping, but it also aims to reduce the crop water stress, and that means increased yield, because if we reduce the stress, then we've got more yield. And also, of course, there's less risk of drainage and nutrient leaching and the accompanying nitrous oxide emissions. So we're lowering the greenhouse gas emission profile of that site by using these precision methods. So that's sort of, in a nutshell, what the program was about and some of the outcomes of that program.
So, Carolyn, obviously this was all being done on farm. Presumably some of these growers were arable growers. Were they all arable growers? What was the mix of farm types that you were working with?
Yes, so we worked closely with FAR to pick our farm sites, as you know, Alison. So we had 3 arable farmers in Canterbury and Otago, and we had 3 arable farmers in Hawke's Bay, and we had a fresh vegetable grower in the Hawke Whenua. And then we also had trial sites at the Massey University, arable plot, and at the Plants and Food Lincoln site. So our trials were well distributed around the country. And also, I suppose, because we were developing these sort of new methods for irrigation scheduling, we really wanted to work very closely with farmers to make sure that what we were doing made sense to them and was operational and was something and was concepts and methods that they could actually pick up and run with. So we couldn't have done this without the farmers and growers that participated in this program.
So presumably you selected the farms to represent a range of different situations where, for example, some farms might have very uniform soil and other farms might have a lot of variability. Is that correct?
Yes, we did do that, Alison. There were quite a few farmers that put their names forward to participate in the trial, and we had to sort of narrow it down a bit. But the method that we took and the lead science group within the program, plus our industry advisory group, was to try and find a good range of farms, so that spread across the climatic regions of both islands and also on different soils, different soil types, but also different amounts of soil variability, and also, of course, different irrigation systems, although most of them were using the sprinkler, low-pressure sprinkler systems, either centre pivot or lateral move. But yes, we did try to get the biggest range of farms that we could. And when we were looking at the soil variability, 7 out of those 8 trial sites had significant variability, so that we could actually divide up the area under the irrigator into more than one soil management zone and vary the irrigation to those different management zones. But one of the farms had quite uniform soils, and this was near Rakaya, and it was wind-blown loess or wind-blown silt over gravels, about 45 centimetres of silt loam, quite uniform over the 100-hectare area that we were looking at. But there we were able to work with soil moisture monitoring. So we installed sensors into the field and worked with the farmer to improve the timing and the amount of irrigation.
Tell us a little bit, about what the real-time soil monitoring system actually is.
Yes. Okay. So there's the 2 steps. So, and I suppose that this is the precision agriculture approach. So you map, monitor, manage. So if we can map the variability, then we can monitor. Then we use that map to guide the monitoring. And if we're monitoring, and if we've got the right technology out there, we can actually manage our crop to handle the variability as it exists. So perhaps I should start with the precision mapping, and then I'll talk a little bit about the precision monitoring. So the precision soil mapping that we used was we used sensor surveys. So there's various sensors that you can attach to the back of a farm bike with data loggers and accurate GPS. This accurate GPS is the key. So that we can, as we pull the sensor across the soil, we're getting a reading back from that soil every second, and that's a geolocated position. So we get all that data and we can use it to produce a map. So the sensors that we used, one of them is called an electromagnetic sensor, and that's monitoring the apparent electrical conductivity of the soil. And you might think, well, what on earth is that telling us? Well, it's actually responding to the soil texture and the soil moisture. And these are 2 key parameters that soil scientists map soils on the basis of the texture and the drainage characteristics, so the texture of the topsoil and the drainage characteristics. So the electromagnetic sensor is pretty good at showing those differences in the soil. The other sensor was a gamma sensor that we developed, a method. The gamma sensor is used quite widely over in Australia, and it's better suited to dry soils, whereas the electromagnetic sensor we use on wetter soils. But what the gamma sensor is picking up is the naturally emitted radioisotopes that are in any soil at very, very low levels. And from that we can infer differences in the soil parent materials and in the weathering of the soils. So if we've got a young alluvial soil next to an older, more stable soil, then the gamma picks that up very nicely. So the 2 of them work together to help soil survey produce precision boundaries and precision soil maps for the area under the irrigator. So it was that precision mapping that's the first step. And as I was saying, in 7 out of the 8 cases, the precision mapping, supported by ground truthing, digging holes and looking at the soil profile, showed that ideally we needed to define more than one soil management zone, and we needed to vary irrigation to these different management zones. At one site, which was the Rakaya site, the soils were uniform, so we only defined one soil management zone under the irrigation system. So then the next step was to do the precision monitoring. And for that, we, in our program, and this was led by Jagat Ekanayaka, we developed wireless sensor networks where we could put soil moisture sensors into the field and then attach that to a node. And the node has got like a little computer in it, a little microcontroller and a radio, and that wirelessly sends that soil moisture data to a gateway, which we normally put at the pivot centre, and from there it goes to the cellular connection. It can go to remote cell phone apps. So we developed this real-time soil moisture monitoring system, and during the time that we were developing these methods, there was a communication revolution, I guess, that we've all been part of, with our smartphones and our being able to turn on the heating on the way home in the car and all that sort of thing. So these real-time monitoring systems are available commercially now, and there's quite a range of them out there. And during the course of our 6-year program, we were continually upgrading the communication component, the way that we send the data from our sensor that's in the field to your smartphone app or to your irrigation control software. The communication protocols were continually being upgraded. And the one that we ended up with was the NORA system, which can communicate from that up to 10 kilometres away from that sensor in the ground at very low power. And so it has very long battery life. So these wireless sensor networks will enable us to do that precision monitoring. We started out with the soil moisture monitoring, but then Hamish Brown of Plant and Food was also interested too, and this was really a strength of the program. We were looking at the soil moisture status and using that to trigger irrigation, but what's the crop doing? So we also wanted to monitor the state of the growing crop. So Hamish used radiometers. He used a range of crop sensors, but one of them is called a radiometer. And so he mounted the sensors above the crop. So we had sensors in the soil below the crop and sensors above the crop. And what that was monitoring very accurately the temperature of the crop canopy. Now, when the crop is fed with plenty of water, ample water, it's actually transpiring and evaporating at its potential rate, and it has that evaporation has a cooling effect. But as soon as we detect the canopy was starting to warm up slightly, that means that it's becoming water stress. The leaves are closing up their stomata because it can't access enough water from the soil. So the radiometer is able to pick up crop water stress, and Hamish developed a method to predict the daily crop water use, which of course is very useful for scheduling. So using these two technologies together, we can provide the information that the farmers and the growers really want to know to decide on their amount and timing of irrigation, and remembering that we're doing it for different parts. We're not just doing it for one uniform area under the irrigator, but if we decide the variability is sufficient, then we would be monitoring those different management zones. So that's the precision mapping and the precision monitoring. So then, of course, we need the precision technology to manage this, and there's various procedures out there, but of course the variable rate irrigation systems are particularly powerful because they can switch individual sprinklers on and off along the boom of the centre pivot of the linear moves. So when we have software that can control individual sprinklers switching on and off as the pivot moves across a field, and when we've got that decision support tool for the software that runs the variable rate system, then, as one of our farmers said to us, we have the Rolls-Royce of irrigation systems.
So, I mean, we've done the 6 years worth of research. What's the next stage to be able to transfer this out, get it taken up and adopted by the growers? Is this economically feasible for growers to be able to implement this kind of mapping and monitoring system on their farm?
Yeah, I really think it is. You know, we're asked this question a lot, and when I start to talk about the high-tech systems, then people often say, oh, but not everybody has those high-tech systems. But I think the concepts behind what we've been talking about can be applied at any level. Now, so if a farmer knows that they've got some sort of, and soil variability is often the major component. Farmers and growers often know if they get variable yields from a field, and they wonder why they've got a twofold difference in yield from one field. It's often the soil. And so if they can sort of delineate those different management zones and then think about how they can vary the amount of irrigation and the timing of irrigation to those two zones, then the precision irrigation becomes possible at different levels of technology.
So is there a plan to sort of take the research results and implement a major extension program to make growers aware of this? What are you planning to do?
I think we have worked very closely with industry, Alison, through this. We've worked with Lindsay New Zealand, who developed the variable rate irrigation system. We've worked with Waterforce, who've been very supportive with providing water monitoring. And we've worked with Agrioptics, who are the precision ag company out there, and Hydro Services, Streets Instruments. You know, and certainly with FAR and DairyNZ. We've sort of worked closely with all these people, and I think there has been uptake of the precision irrigation concepts and tools. I think there's between 5 and 10% of centre pivots now have the variable rate control. But then, having bought the smartest technology, there needs to be an understanding about how you run that, and that's where the decision support tool for the smart new machine is the bit of the research that we were focusing on, I guess, and trying to work alongside farmers, on a one-to-one basis, and with the industry support groups to try and help the development of the decision support tool for these new technologies. And I guess a lot of farmers now have soil moisture monitoring coming onto their smartphone apps, and that's something that wasn't there 10 years ago. But now it's pretty easy to get some real-time soil moisture data and real-time information about the irrigation system onto a smartphone app. And that's really useful information. So we've sort of been to field days and workshops and farmers' meetings trying to just present the results of this research as widely as we can.
Mm. Thank you very much, Caroline. That's really, it's great to see a program, delivering tangible outputs for growers. And obviously in the current climate, anything that, increases water use efficiency is going to make a big difference to farmers being able to meet, a lot of the environmental compliance requirements that are going to be coming along over the next sort of few years. So thank you very much, Caroline, for a very interesting program of work, and good luck for future work that you're planning to do.
Thank you, Alison. Yeah, that was my pleasure to talk to you.
Okay, thank you, Caroline. And
Thank you,
listeners, and have a great day on the farm.
Thanks for tuning in to Cut the Crop, presented to you by FAR. If you'd like to know more about any of the topics discussed or have any suggestions for future topics, go to www.cutthecrop.co.nz.